Hello everyone. So how are you? I hope that you're fine and well at home, and considering that our holidays have been moved forward, we haven't had the chance to complete the next few chapters that we need to do for term 1. So this lesson is about matrices. I'm not doing this in detail. I'm just doing whatever we need so that we could be doing matrices for transformation. Yeah. So the basic idea for matrices is that we have to add them. Yeah. So if we have a simple matrix, like for example, a 2 by 1 matrix and another 2 by 1 matrix, and we have to add them together. Yeah. We always need to look at the position of the element of the matrix. So if 1 is at row 1 and column 1 right here, we have to add with 3, which is also at row 1 and column 1 for the next matrix. Yep. So all we have to do is just add them up and get the answer. So 2 plus 4 will give us 6. So that's how we add matrices. Yeah. So subtraction is also pretty easy. It's pretty simple. So 1 take 3 will give us negative 2. 2 take 4 gives us negative 2. So this is basic matrix addition and subtraction. Yeah. So how do we multiply matrices? So if we are multiplying a matrix by a scalar, so for example, like a constant number here. So 5 times a matrix will, you actually have to times every single element of the matrix by 5. So that's what I'm doing here. So this will give us a value of 5, 10, 15, and 20. So what if we are multiplying one matrix with another? So in this example, I'm doing multiplying a 2 by 2 matrix by a 2 by 1 matrix. Yeah. So in order to do that, we always have to take the first row of the first matrix and the first column of the next matrix. Yep. You can't do it the other way around because that's not going to work. Yep. For example, if you're doing the first column of the first matrix and the first row, that's not going to work. Yep. It must work in one way and one way only. So first row times by the first column. Yeah. So what I'm trying to say is for the first row, you have 1 as the first element. And for the first column, you have 5 as the first element. We times 1 and 5 together and plus the second elements. Yep. So that's 2 times 6. Yep. And we'll work that out later. So after we have done the first row, we have to focus on the second row. So the second row has a value of 3, 4. And the first column has a value of 5, 6. So 3 times 5, yep, will be here. And plus 4 times 6, we will put it here. And by solving them, we get the values of 17 and 39. So that is how we multiply matrices. So now we have to also understand the idea of identity matrix. It's a really powerful matrix. It has many uses, and we will know that really soon. Yep. So an identity matrix will always have sort of like the values 1, 0, 0, 1 for a 2 by 2 matrix. Yep. So at this moment, we are only doing identity matrix for 2 by 2. Yep. So if we have an identity matrix and we are timesing it by a random matrix, let's say a 2 by 1 matrix that has a value of 5, 6. Yeah. So using the multiplication of matrix that we have done just now. So the first row times by the first column gives us 1 times 5 plus 0 times 6. Yeah. So the first one goes with the first one. The second one goes with the second one. Yeah. After we have completed the first row, we have to focus on the second row, which has 0, 1 and 5, 6. So 0 times 5 goes together, 1 times 6 goes together, and you have to add them. Yeah. So this gives us 1 times 5 plus 0 times 6 is 0. Yeah. So 5 plus 0 is 5, and 0 times 5 is 0, plus 1 times 6 is 6. So 0 plus 6 gives us 6. So this means that any random matrix that we choose will return the same value if we times them with an identity matrix. Yeah. So timesing a matrix with an identity matrix actually returns the value of the original matrix. So now that we have covered addition, subtraction, multiplication, we are focusing on division. So just now when we were doing multiplication, we sort of did this, yeah? So a matrix of 1, 2, 3, 4 times by another matrix of 5, 6 gives us a value of 17 and 39. Yep. So if we have a question like this, yep. So 1, 2, 3, 4, the matrix 1, 2, 3, 4 times by mn equals to 17 and 39. How do we solve this? Yep. We know that the value of mn is 5, 6. Yep. And sorry, if we are dividing this using a normal algebraic way, in order to find mn, all we have to do is move this matrix across the equal sign, and considering the relationship is a times, we sort of divide them. But does this work for matrices? No, they don't. Okay, so we can't do a direct division for matrix. It doesn't work. Yeah. So because of that, we have to understand what is inverse matrices. Yeah. So for inverse matrices, we are only focusing on how to inverse a 2 by 2 matrix. Yeah. So if a matrix A has an element of A, B, C, D. Yeah. So we will always take the sort of like the element of row 1, column 1 as A, row 1, column 2 as B, and the rest as C and D. Yeah. To get the inverse matrix, we have to actually put a negative 1 in front of the A. So that means that this is the inverse of matrix A. Yeah. Equals to 1 over AD, means that these two, the product of these two values, A and D, take the product of B and C. Yeah. And after that, we have to write the matrix, but we have to switch the sides. So can you see that A and D have switched sides? Yep. And then B and C, we have to switch the signs. Yep. So I'll just repeat this. To get the inverse of a matrix, we have to 1 divided by the product of the first and the fourth element. Take the product of the second and the third element. Yep. And then for the matrix, we have to switch the sides. Yep. For the first one, and switch the signs. Yep. So yeah, and in many books they will write a determinant of A. So what's the meaning of determinant? The determinant is actually AD take BC. So sometimes they don't write it as 1 over AD take BC, they write it as 1 over determinant A. So that's gonna be this one. Yep. So now let's do some inversing work. So let's say a matrix has the value 1, 2, 3, and 4. How do we actually inverse it? Yeah. So to inverse matrix A, we need to 1 over the determinant, which is we times the first and the fourth values together. Take the product of the second and the third value. Yep. And then for the matrix behind it, we have to switch the sides. And then we have to switch the signs. Yep. So by doing this, we have 1 over 4 take 6. If we simplify it, it's going to be negative 1 over 2. Yep. I will just copy and paste this down. So nothing has been done yet. And all I did was I times, oops, sorry, I went a bit further. So yeah, so all I did was this is like the scalar. So I just times them in and I got this in the end. So that means that the inverse of my matrix A, which is initially 1, 2, 3, and 4, the inverse of my matrix A has a value of negative 2, 1, 3 over 2, and negative half. Yep. So now that we have done this, okay, what is the relationship between inverse and identity matrices? Yep. So if I times them together, yep, the inverse of matrix A and A, if I times them together, yep, by doing the inverse work just now, we have gotten this matrix, yep. So in the inverse of matrix A is this one, negative 2, 1, 3 over 2, and negative half, yep, times by the matrix A, which was 1, 2, 3, and 4. Yep. So just now when we were learning this, we were doing a 2 by 2 matrix times by a 2 by 1 matrix. And can you see now we are slightly moving this further? We are timesing a 2 by 2 matrix with another 2 by 2 matrix. But it's pretty easy. Yep. We just have to work it out one by one. Yep. So if we just focus on the blue boxes right here. Yep. So the first row for the first matrix and the first column of the second matrix, you always remember to get the first row of the first matrix first. Yeah. So if we times the values together, yeah, we need to have -2 times with 1 added with 1 times by 3. So that's what I'm doing. Yeah. So this will be actually what I get from timesing row 1 with column 1. Yeah. So it's going to be row 1, column 1 for my matrix right here. So now we focus on sort of like the red circle one. Yeah. So the red circle one is focusing on row 1 and column 2. Yeah. So after we are done with column 1, we focus on column 2. Yeah. So for column 2 and row 1, we have to times the first elements together. So that's -2 and 2 together, added by 1 times 4 together. And can you see that this is being placed at row 1 and column 2 of this matrix, because this is row 1, column 2. So the result is going to be here. Yeah. And if we keep going and keep doing for the next two, for the row 2, yep, row 2, column 1 will be written here. Yeah. And the values of row 2, column 2 will be written here. Yeah. So by simplifying them, it gives us 1001. So what does that tell you? That this is actually an identity matrix. Yeah. So this actually shows us that if we times sort of like the inverse of a matrix with a matrix, or if we times a matrix with an inverse matrix, we will always get an identity matrix. So coming back to the previous question where matrices cannot be divided, yeah? So this was what happened just now, yep, and we were trying to find the value of m and n, and we know that we can't divide it, yep. So how are we going to solve questions related to this? So matrices division. So if we have a matrix A and if we have the inverse of matrix A, yep, this was previously solved already, yeah. And we have the original question that we need to find the value of m and n. We know that m and n is actually 5 and 6, but how do we do it? Yeah. So in order to get rid of my matrix A, I sort of put an inverse of my matrix A right in front of this matrix. Yep. You have to be aware that if you are trying to get rid of this needs to be in front of this matrix. Yep. So I put this right in front here. So if I add an inverse matrix for my left hand side of my equation, I also need to add an inverse matrix on the left hand side of sort of like the left side of my other side of the equation. Yeah. So we know that the inverse of matrix A times by A will give us an identity. Yeah. And these ones we have to multiply them. Yeah. So these ones will result in an identity matrix times by m and n. So this will return a value of m and n. Yeah. And when I times these two matrices together, this will return me a value of 5, 6. And therefore, we can find that mn has a value of 5, 6. So this is how we are actually dividing matrices. We are adding the inverse in front of the matrix that we do not want, so that we are actually moving this across the equal sign. Yeah. So yep, that is the end of the lesson for understanding matrices, and we will be using that a lot in our transformation lessons later on. See you then. Bye.